Bismillahirrahmanirrahim. Hello everyone. I hope you are all doing well. I welcome you all in class of Real Analysis by Robert G. Bartle. In today's lecture, we will discuss epsilon neighborhood of a point. Before going to start the proper definition of epsilon neighborhood of a point, firstly we discuss this concept with a simple example. If we consider any real number a, suppose this is 1. You know there are many infinite points which are nearly close to 1. Some of them are greater and some of them are less than 1. For example, 0.9 is a real number which is less than 1 but close to 1. Similarly, 0.95 is also a real number which is close to 1 but less than 1. Similarly, 0.99 is again a real number which is nearly close to 1 but again it is less than 1. Similarly, there is a real number 1.1. This real number is greater than 1 but close to 1. 1.01. Again this real number is greater than 1 but close to 1. 1.001. This real number is close to 1 and greater than 1. So you can find there are infinite many real numbers which are nearly close to 1, either from left or right side. These all points which are nearly close to 1 form the neighborhood of point. So this interval, suppose 0.99, 0.99 to 1.001, this interval contain 1. So we can say this interval is an open is a neighborhood of this one. Similarly, you can find another neighborhood of 1, 0.95 to 1.01. Now, what is the epsilon neighborhood? Suppose this is my real line and this is my point x is equal to 1 or a is equal to 1. Now, if you consider all of the points at some epsilon distance, suppose at epsilon distance, you increase and decrease 1 by epsilon distance, you can reach here 1 minus epsilon after decreasing 1 with epsilon, and if you add or increase 1 with epsilon, you can reach at 1 plus epsilon. So this interval 1 minus epsilon to 1 plus epsilon is also a neighborhood of this point x is equal to 1, and this is called the epsilon neighborhood. So actually epsilon neighborhood is a neighborhood of a point when you consider all of the point at some epsilon distance. So how can we define this definition properly? Let a is any real number and epsilon is a positive real number. Then epsilon neighborhood of a is the set of all points. The epsilon neighborhood of a point is, firstly, this is a set. The epsilon neighborhood of a point is always a set, and it is denoted by, in this book, by the notion V epsilon A. And this set is equal to set of all real numbers whose absolute difference is less than epsilon. Next, by using the property y absolute less than b, where b is any real number, you can open this absolute as minus b less than y, y less than plus b. So this can be written as minus epsilon less than x minus a less than epsilon. By adding a on both sides, we have a minus epsilon less than x less than epsilon plus a. So this open interval, this is x is equal to a, and at epsilon distance there is another point which is a minus epsilon, and this is another point which is a plus epsilon. So this open interval a minus epsilon to a plus epsilon This is called epsilon neighborhood of A. The point about which we are going to find the neighborhood, this point x is equal to A is called actually center of this neighborhood. So x is equal to A here, center of this neighborhood. For example, epsilon neighborhood of 1. This is simply an open interval. By setting A is equal to 1 here, we have 1 minus epsilon to 1 plus epsilon. So this notation represent the epsilon neighborhood of 1. If you fix the value of epsilon, which is 0.005, suppose, then the epsilon neighborhood of 1 with epsilon 0.05 is the open interval 0.95 to 1.05. You can find infinite neighborhood of 1. For example, if you take epsilon is equal to 0.1 and other epsilon neighborhood of 1 is 1 minus 0.1 to 1 plus 0.1. This is equal to 0.9, 1.1. So this is another epsilon neighborhood of 1. You can notice that in both of the neighborhood, the center of this interval is 1. How you can find epsilon center of this interval? The center of this interval is just arithmetic mean of this interval. That is, you can find the mean of this interval 0.95 plus 1.05 over 2. This will give 2 over 2, which is equal to 1. That is the center of the interval. Similarly, if you find the mean of these numbers 1.1 plus 0.9 over 2, this is also equal to 1. So there are infinite many neighborhood of 1 by just setting the different value of epsilon. So I hope now you have a clear understanding about a neighborhood of a point. Next we discuss theorem 2.2. This is interesting theorem. This theorem says if A is any real number and if x belongs to the neighborhood of A for every positive real number epsilon, then this x is equal to A. Actually, what does this theorem says? X is any real number that always belong to this neighborhood of A. This is possible only when x is A. In other words, this theorem simply says that the center is the only point which always belong to the neighborhood. You can understand this concept by the example of circles. For example, this is center of this circle. Now you can form infinite many concentric circles of different radius, but always you can notice that this point, that is the center, always belong to all of these circles. So actually, what is epsilon in this example? Epsilon is actually radius of the circle. Radius of the circles. So for any epsilon, for any positive real number epsilon, if you say some real number x belong to this neighborhood, then that real number is always actually center of the neighborhood. So now we prove if a particular x satisfies this inequality, that is the definition of epsilon neighborhood. In other words, if you say if a particular x belong to epsilon neighborhood of epsilon neighborhood of A, this implies x minus A is less than epsilon for every epsilon greater than 0. Then by theorem 2.1.9, which says if A is any real number such that 0 less than or equal to a is less than epsilon. This inequality hold for every epsilon. This is possible if a is equal to 0. Actually, what does this inequality say? This inequality says you have to think that which non-negative real number is always less than every positive real number. So this is the question. Which non-negative real number is always less than every positive real number? So there is only one non-negative real number which is always less than every positive real number, that is 0. So in other words, this inequality hold, if this inequality hold for every positive real number epsilon, it means here a is 0. So applying this inequality applying this result over this inequality, we have 0 less than or equal to x minus a absolute less than epsilon. This hold, because this inequality hold for every epsilon, this implies absolute of x minus a is equal to 0. This implies x minus a is equal to 0 or implies x is equal to a, which is required. Next we discuss example 2.2.9. We can prove this example by using two different ways. The first method is in the first method. What is the statement of this example? This example says if we have a set U which consists on the open interval 0 to 1, that is our U is a set that consists on open interval 0 to 1. If a is any real number belong to U, and let epsilon be the smaller of the two numbers a and 1 minus a, we have to show that the epsilon neighborhood of a is always contained in U. We have an open interval 0 to 1. We have to choose any real number a from U. Epsilon is the smaller between the number a and 1 minus a. Then we have to find epsilon neighborhood of a. Epsilon is either a or 1 minus a. We have to find epsilon neighborhood of a. This is our target. And next we have to show that this epsilon neighborhood of a is always contained in U. In the first method, this is method number 1. This is actually a numerical approach. In this method, I will take 3 different cases. In these cases, I will take 3 different values of a. The first value lies at the center of the interval. In the second case, I will take a from the right end of the interval, and the last I will take a from the left end of the interval. So if a is 0.5 belong to U. If a is 0.5, then 1 minus a is also 0.5. It means your a and 1 minus a both are equal. So in this case, you can take either a is equal to epsilon equal to a or 1 minus a, because both are equal. So in this case, epsilon neighborhood of a is can be defined as, this is the definition of epsilon neighborhood of a. Now put epsilon is equal to a, because we have to take epsilon either equal to a or 1 minus a. But here a and 1 minus a both are equal, so I am taking epsilon is equal to a. So by expanding the definition of epsilon neighborhood of a, we can take minus epsilon less than x minus a less than epsilon. Now set epsilon equal to a here, we will get inequality minus a less than x minus a less than epsilon, less than a. By adding a to each side, we have minus a plus a less than x, x less than a plus a. Minus a plus a, this will be equal to 0, and 0 less than x, x less than 2a. As a is 0, 0.5, so 2 times a equal to 1. It means this interval for a is equal to 0.5 becomes open interval 0 to 1. So it means your x belong to 0 to 1, and 0 to 1 mean your set u, and this is equal to epsilon neighborhood of this. What is this? This actually represent the value of epsilon neighborhood of 0.5. So in this case, you can notice that the epsilon neighborhood of 0.5 is exact equal to u. Second case, if a approaches to 1, then 1 minus a approaches to 0. So in this case, the minimum of a and 1 minus a clearly equal to 1 minus a. As a is 1, a is approaches to 1 and 1 minus a approaches to 0. So minimum of 2 is 1 minus a. So take epsilon is equal to 1 minus a, because epsilon is minimum of 2, minimum of these two. So take epsilon is equal to 1 minus a. Next, applying the definition of epsilon neighborhood of a. This is the definition of epsilon neighborhood of a. Put epsilon is equal to 1 minus a. So when you put here epsilon is equal to 1 minus a, this become minus 1 minus a, and this is equal to minus 1 plus a, less than x minus a, less than 1 minus a. By adding on both sides, we have minus 1 plus 2a, less than x, x less than 1. As here a approaches to 1, this implies 2a minus 1 approaches to 1. A approaches to 1 implies 2a approaches to 2. This implies 2a minus 1 approaches to 1, and 1 is greater than 0. It means 2a minus 1 is greater than 0, less than x, x less than 1. It means this interval 2a minus 1 less than x, x less than 1 always contained in u. This interval 2a minus 1 less than x, x less than 1, and this is greater than 0. This interval 2a minus 1 to 1, this is a subset of 0 to 1, which is equal to u. So the epsilon neighborhood of a at epsilon 1 minus a is contained in u. Case number 3, if a approaches to 0. When a approaches to 0, clearly 1 minus a approaches to 1. For example, your a is 0.001. 1 minus a is equal to 0.999, which is close to 1. So in this case, 1 minus a approaches to 1. Now the minimum of a and 1 minus a, which is minimum between a and 1 minus a, clearly this is a. So set a is equal to epsilon. Now the epsilon neighborhood of a at epsilon, this is equal to minus epsilon less than x minus a, sorry, this is equal to epsilon here. Now set epsilon is equal to a. This gives minus a less than x minus a less than a. By adding a in each side, we have 0 less than x, x less than 2a, and 2a is always less than 1, because when a is approaches to 0 and a is positive, so 2a also approaches to 0, and this is also positive, so it is always less than 1. So again you can notice that this interval 0 less than x, x less than 2a less than 1, this interval 0 to 2a, this is the subset of the interval 0 to 1, which is equal to u. So again, in this case, your epsilon neighborhood of a is a subset of u. So in all of these three cases, you can notice that always when epsilon is the minimum of a or 1 minus a, your epsilon neighborhood is always subset of u. Next, this is method number 2. and I will prefer that you use this approach in your exam. Let epsilon is minimum of a and 1 minus a. We need to show that the epsilon neighborhood of a is subset of u. As we know that the epsilon neighborhood of a can be defined as, let x is any real number from this epsilon neighborhood of a, then we can open this definition, this absolute, as minus epsilon less than x minus a less than epsilon. By adding on a on both sides, we have a minus epsilon less than x less than a plus epsilon. Next, I need to evaluate the value of these two numbers, a minus epsilon and a plus epsilon. Say this is inequality number 1. Next, we use the definition of epsilon. What is epsilon? Epsilon is actually minimum of these two numbers. So the definition of minimum says this epsilon should be less than or equal to both of these two numbers, because this is the minimum of these two numbers. So since epsilon is less than or equal to a, this is the first number. Now I want to find a minus epsilon. So by multiply a minus on both sides, this gives minus epsilon greater than or equal to minus a. Adding a on both sides, we have a minus epsilon greater than or equal to a minus a, which is equal to 0. This shows a minus epsilon is greater than or equal to 0. Say this is 2. Since epsilon is also less than or equal to the second number 1 minus a, adding a on both sides, we have a plus epsilon less than or equal to 1. This shows that the right end point of this inequality is less than or equal to 1, and the left end point of this inequality, that is a minus epsilon, is greater than or equal to 0. So inequality combining 1, 2 and 3, we have the inequality number 1 can be written as 0 less than or equal to a minus epsilon. A minus epsilon is less than or equal to x. X is less than a plus epsilon, and this is less than or equal to 1. It means this interval a minus epsilon to a plus epsilon, this interval is contained in 0 to 1. Thus we have your x lies between 0 to 1. From here you can notice that your x lies between 0 to 1. In other words, your x lies between u, because your u is open interval 0 to 1. This implies your x belong to u. As x is an arbitrary element of the epsilon neighborhood of a, this shows that this epsilon neighborhood of a is subset of u, or you can notice clearly from here, this is your epsilon neighborhood of a, which is subset of open interval 0 to 1, that is u. That is epsilon neighborhood of a is subset of u. And it completes the proof. Next example 2.9c. This is also very interesting example. This example says if x and y belong to epsilon neighborhood of a and b, your x belong to epsilon neighborhood of a, your y belong to epsilon neighborhood of b. We have to show that their sum x plus y belong to 2 epsilon neighborhood of a plus b. In other words, we have to show that the epsilon neighborhood of a plus b with two epsilon neighborhood. This this 2 epsilon neighborhood of a plus b contain x plus y. This is our target, and for this we will show that x plus y minus the center a plus b, this absolute difference should be less than 2 epsilon. This is our target to show. Here, considering this definition of epsilon neighborhood of a, when your x belong to epsilon neighborhood of a, you can write it as x minus a less than epsilon. Similarly, when you say your y belong to epsilon neighborhood of b, this gives y minus b absolute less than epsilon. Now I have to show x plus y minus a plus b absolute less than 2 epsilon. So consider this expression and using the triangle inequality. We can write it as this expression as x minus a plus y minus b by combining a with x and y with b. Now applying triangle inequality, you know the triangle inequality says x plus y absolute is always less than or equal to x absolute plus y absolute. So applying this inequality in these two parts, this can be separated as less than or equal to x minus a plus y minus b absolute. By using 1 and 2, this is less than epsilon and this is also less than epsilon. This becomes x plus y minus a plus b absolute less than 2 epsilon. And what does this show? This shows x plus y belong to 2 epsilon of a plus b as required. So in this lecture, we have discussed some important examples and theorems which are related to epsilon neighborhood of a point. Inshallah, in the next lecture, we will discuss exercise questions which are related to this topic. So if you find this lecture helpful, kindly like, share and subscribe my channel. See you in the next lecture. Take care. Allah Hafiz.